In this video, we're going to take a look at section 9.1, the square root property and completing the square. Some of this you've seen before, but there are some theorems here you're going to want to write down. And if I go too fast, you're welcome to pause it and write down the theorems. And one thing that's important to note in this section is that everything we do now, we can do with complex numbers. So that's going to add a new level of excitement to what we do here. So two theorems to start off with. First of all, the zero product property. This is a theorem we've been using since Algebra 1 to solve quadratic equations. And it says that if you have a product, A times B equals 0. That means that either A equals 0 or B equals 0. And you've applied this before. If you factor a quadratic and you have something like x plus 1 times x plus 4 equals 0, the way you solve it is by setting these factors equal to 0, because we know that one of them, at least, has to equal 0. And that gives us a process for solving these guys. So you've used the zero product property before. But the new property in this section that you may not be aware of is the square root property. And the square root property says, now if we have an expression or an equation that has a squared in it, like x squared equals k, that means we need to look at both solutions. That means that we can square root both sides and get x equals the positive square root of k or x equals the negative square root of k. We have to consider both solutions here. And something you shouldn't be scared off by is this business here. This just means that x and k could be elements of, we know that symbol is elements, of the complex number set. So we could have i's floating around and complex numbers floating around our solutions today. Okay, so a couple examples of that. First of all, solve x squared equals 48. I can take the square root of both sides, and I would get x equals plus or minus the square root of 48. That plus or minus notation is nice. It means that we have two answers here, and we're going to put it in one nice little expression. And we know that simplifies as x equals plus or minus 6 root 3. And again, keep in mind that this notation means two solutions, 6 root 3 and the opposite of 6 root 3. And I apologize that my 3's are so awful on this program I'm using. So two solutions, but this is totally acceptable for representing both solutions. Here's a second one. What if we have something in parentheses that's already being squared, x plus 3 squared equals negative 50. I can do the square root of both sides. I have x plus 3 equals the square root of negative 50. And we can certainly, and it's plus or minus, whoops. And I can certainly clean this up. This means x plus 3 equals, I know how to simplify the square root of negative 50. It is 5i root 2, so I have plus or minus 5i root 2. And notice where the plus minus goes in this expression. And finally, to solve it, I'm going to move the 3 to the other side. So x equals negative 3 plus or minus 5i root 2. And that is a nice, clean way of representing both solutions. Okay. Next problem we're going to look at. Now we want to solve by a technique called completing the square. I think this is a technique you've seen before, but in case you haven't, I've gone to your textbook and taken a picture of the steps required. I don't know if I'd advocate that you need to write down all the steps. I'm going to do 3 examples here, and then you might want to see how they flow through here. But I'm going to point out a couple key steps. First of all, we have to make sure that we have a term that has coefficient 1 at the beginning. So we need to have 1x squared. And also, we want to put ourselves in a position that we have a perfect square trinomial. Because if you go back a couple slides, we basically want to have something that looks like this. We want something squared that I then can take the square root of. So here's how this works. I'm going to rewrite it, x squared plus 6x, but I'm going to move the 4 to the other side, so it's a minus 4. And what I need here is I need a number that will allow me to complete the square. And here's the procedure. I actually moved down to the next line of work. I know that the trinomial will end up being x plus 3. It will end up being half of the 6. X plus 3 squared. Well, x plus 3 squared is x squared plus 6x plus 9. So this trinomial and this are equal to each other. And I got that by taking half of 6. But I can't just add 9 to one side. I have to add 9 to the other side, so I now have x plus 3 squared equals positive 5. And now this problem I have here looks like what I had 2 slides ago. I can now take the square root of both sides. I have x plus 3 equals plus or minus root 5. Move the 3 over. X equals negative 3 plus or minus root 5. And that looks nice. So again, I can go to the next slide and follow these steps, but I think if you follow along with my examples, you'll see where all these steps are represented within the work I do. So if you feel free and you want to come back and write the steps down, that's fine. But if you can follow along without them, that's fine too. So I'm going to do 2 more examples of this. Here's my second example. X squared plus 5x minus 1 equals 0. Going to move the 1 to the other side. X squared plus 5x equals 1. And now I move down to the next line of work. I envision filling this in. I know it's going to be x plus half of this term. So that's 5 halves. What has to go here is the square of 5 halves. 25 fourths. It's not nice, but you can verify that this trinomial is the same as this expression here. And if I add 25 fourths to one side, I have to add 25 fourths to the other side, excuse me. If I add to one side, I have to add to the other side as well. So now I just have a little cleanup to do. This side, don't be too scared off by. 1 is equal to 4 fourths. 4 fourths plus 25 fourths is 29 fourths. So if x plus 5 halves squared equals 29 fourths, I take the square root of both sides. X plus 5 halves equals plus or minus the square root of 29 fourths. 29 fourths, that's plus or minus root 29. Conveniently, I know what the square root of 4 is. That's 2. And now I need to take the 5 halves and move it to the other side. I've not done a good job here of leaving myself room, but I'll have x equals negative 5 halves plus or minus root 29 over 2. But I see that both of these have the same denominator, so I can write it as one fraction. Negative 5 plus or minus root 29 all over 2. One nice expression here. So that's a lot of stuff on one slide. So you might want to go back and redo that work to verify what we have here. One last example. Here's our last example. X squared plus 3x plus 7 equals 0. So I'm going to start the same way. I get x squared plus 3x. Move the 7 to the other side. I'm going to have negative 7. Fill in the next step. X plus 3 halves squared. That means I'm going to need a 9 fourths here, which I will then add to the other side as well. This other side here will always require a little bit of cleanup. Negative 7 plus 9 fourths. So I'm going to do a little work up here. Negative 7 equals negative 28 fourths plus 9 fourths. That is going to come out as negative 19 fourths. That doesn't sound promising, but we're going to deal with it. X plus 3 halves squared equals negative 19 fourths. Now I'm going to take the square root of both sides. I will have x plus 3 halves. And think about what's going to happen here when we take the square root of both sides. Square root of 4 is easy. That's 2. And I have the square root of negative 19. This will be plus or minus I root 19 over 2. Not nice, but it's all written conveniently. We have our I for the negative 19, and we still have square root of 19 floating around. Now I'm going to subtract the 3 halves over. I'll have x equals negative 3 halves plus or minus I root 19 over 2. And conveniently, I have the same denominator, and you'll see that this occurs in most of the problems we do, where we can combine them with a similar denominator. We have negative 3 plus or minus I root 19 over 2. So we will get complex number solutions in a lot of these problems. So completing the square, when we meet in class tomorrow, we'll do a lot of board problems. You have a lot of chance to ask questions, but it combines a lot of your skills. So that's it for completing the square.